My name is Larry Stevens. I'm actually the curator of biology here at M&A, but today talking with you about some of our holdings in geology and the stories that M&A has been able to put forth on life on the Colorado Plateau here. We live in a time of change. Is this a dramatic departure from the way change has happened on Earth before? The history of our geology in this landscape particularly tells us that this is what we're going through is completely trivial compared to the kind of dynamics that the Earth has seen here. Colorado Plateau has about 2 billion years of Earth's history below our feet here, and the stories emerging out of those rocks, out of the fossils, and the time frame here are truly prodigious, shocking to us now. Earth is about 4.6 billion years old. It's been a steady history of change. One thing that has contributed to the change in the dynamics and life and the environments we have here on Earth is poop. From the earliest protobacteria in the seas that began to photosynthesize, producing oxygen as a waste product, poop has been responsible for enormous changes on Earth and has moderated the environment, providing critical nutrients into ecosystems for life, and life taking advantage of that in many ways. Today we'll be talking about the science of poop a bit as we move through this. But in order to understand where we are, how we got here, and the landscapes that have evolved around us, what we need to kind of pay attention to is this issue of change and the role of poop in change. With life emerging and coming up and developing, as you can see, from these early algal forms, fish emerging 500 million years ago, coming around to dinosaurs in kind of relatively recent times for us. Time is something that's hard to understand. We have a pathway of time that we've laid out through now billions of hours of human activity to try and understand the rate of change on Earth. And the dynamics of time are so vast that it's impossible for us to actually understand time. In my family, which has been in the U.S. for now 13 generations, the actual family stories only go back to the Civil War. We don't have actual stories that our family members remember prior to the Civil War. And so our perception of time is based on stories, it's based on personal recollections and whatnot. But that time is very difficult to understand. So we use as a substitute for understanding time, we use data, and we can use that as a roadmap. And for the 4.6 billion years that have gone on here, we have no way to intuit what that means. But we can understand time in terms of the positions of these numbers that we're talking about. So I'm going to jump from 4.6 billion years ago, life emerging about 4 billion years ago, to just a matter of 15 million years ago. The time frame in which the landscape that we're on here just began to be understandable as a landscape to us now. This is the time before the San Francisco peaks, before much of the rising of the Colorado Plateau. At that point in our history, we were dealing with a landscape that was probably much like the southeastern U.S. Savanna grasslands, lowland rivers winding through, riparian groves of trees in the landscape here, and at lower elevation. But the animal life that we had roaming around us at that time were recognizable. Rhinoceros, proto-horses, camels, those kind of things were living in North America. Some pretty remarkable predators. The cat and dog lineage arose about that time, 15 million years ago, during the Miocene time. And so it's been a gradual landscape change over the last 15 million years to bring us the landscapes that we see here now. Again, with time and change, we know most about change that's recent. And as we go farther back in time, we have just kind of faint pieces of the story to be able to put together. Coprolites are dinosaur poop, well, any kind of vertebrate animal poop that fossilizes are called coprolites, and those give us evidence of that all the processes of life, including excretion, have been going on all this time. But we gather information from those deposits to be able to understand what animals were eating, how big they were, what age they were, and whatnot. So 15 million years ago was long after the dinosaurs, except for the birds. And so during that time frame, large herbivores roamed the landscape. Elephants, camels, horses, a large number of creatures. Climate was changing. We had ice ages going on back as far as 15 million years ago. Ice ages continuing, virtually up to the present. All of human history has taken place in the interval between ice ages, and so that's a sobering lesson. The transition of life forms and environmental changes here has been quite dramatic. As I said, 15 million years ago, we're living in a lowland, almost tropical kind of environment because the Sierra Nevada did not come up. We had much rain coming in from the Pacific Ocean because the rising of these mountain ranges over the last 15 million years ago in what's called the basin and range erosion that created the rain shadow that we now live in and the arid environments. When the environment becomes arid, what happens is life has to adapt. There are losers and winners. Cacti emerged in this last 10 million years or so, and various desert life forms emerge in that time frame. But many life forms disappeared. Early birds, many of the kind of mesic aquatic animals that lived in the landscape back in those days are gone. Animals like snapping turtles used to be native to Arizona, gone now. In this transition from the Miocene time, from about 15 million years ago to about 3 million years ago or so ago, the Sierra Nevada rise up, block the rain, turn this into an arid land environment, and the whole fauna and flora changes over in response to that. The landscape here is also rising, and as landscape rises, of course, it erodes and creates more rain shadow effects. Features like Grand Canyon are pretty trivial in the geologic story because they've just arisen in the last 5 million years or so. That's a whole different topic. But so we can kind of see this transition going on until the beginning of the Miocene, the end of the Miocene epoch, beginning of the Pliocene epoch, about 6 million years ago, when desert conditions more severe than we have now arose and really allowed plants like cacti and some of our desert plants to emerge. So all this is going on in the context of a changing fauna. Then a funny thing happened 2.6 million years ago. The continents drifted about an inch a year, and for 60 million years, South America was a free-floating island, not connected to any other land masses. That meant it had separated from Gondwana land in Africa, carrying fauna with it, and those animals evolved in their own rights. And a particular group of creatures arose, and among them are the sloths, the armadillos, and the anteaters. Those are a distinctly South American group of critters. And 2.6 million years ago, the first time South America touches North America, creating a land bridge and allowing incredible faunal and floral exchange across the two continents. South America has 150 genera of plants and animals that we have here in the Southwest. And by South America, I mean Chile and Argentina, so far south of the tropics. And in that landscape, there are places, I've been in places in Chile where you're looking around the landscape going, where in Arizona there's brittle bush, there's mesquite, there's creosote bush, and a whole suite of reptiles and amphibians that are quite closely related to our own, not to mention a lot of insects. So it's quite challenging to think about this level of transition, where continents are touching each other, flora and fauna are interchanging, and some species moving north from South America into North America, some moving south. South America didn't have any large vertebrate predators, large mammalian predators, until North America touched. And then the cats and the bears, the raccoons, the otters went down into South America and began to dominate those landscapes. We up here didn't have armadillos, probably not porcupines, and then a whole suite of strange creatures came up. These ground sloths are one of those creatures. And you see a picture over here of a giant ground sloth browsing. The ground sloths were giant animals, much bigger than a grizzly bear. Apparently kind of goofy looking, and walk around on their claws like this. It's clumsy and slow, but very good climbers. We know most about them because their dung is left in some caves in the southwest here. One called Rampart Cave in Lower Grand Canyon, which I went into 2 years ago on an expedition with music for the museum. And that's a remarkably difficult climb to get up. It's nearly a vertical cliff that goes up for 30 or 40 feet. And yet these incredibly large animals were up foraging, they're vegetarians, and foraging on the surrounding landscape there, and coming up into this cave where they probably overwintered. And climbing up almost vertical cliffs that would challenge many of us. So these really big animals are moving up into these secluded places. Well, they're in these caves, and they poop a lot. If you look at the dwarf, we're on the front, the bolus of one of their poops is maybe 6 inches in diameter. So this is one kind of fascinating piece of our natural history here, because the poop can be dissected, and every fragment of plant can be identified as species in that. And of course, this takes a very peculiar kind of person to want to do that much analysis of whole poop. Nonetheless, the information that the poop shows us is absolutely tremendous. It's just incredible, because the poop, these feces that were removed from this cave are 30,000 years old during the height of the Ice Age. And what they do is give us then a portrait of the vegetation around that cave. So this story also has been studied for pack rats. We have the same kind of information for pack rats, and also for elephants. We have 3 species of elephants in the landscape here. I'll say half a dozen species of pronghorn, a big family of which we only have 1 species left now. Giant predatory birds called teratorns flew the skies here. One here with a 13-foot wingspan, so bigger than our biggest other bird in the landscape. A little bit farther to the north, one with a 17-foot wingspan. One in South America with a 25-foot wingspan. From here to Mary. A huge bird that was predatory, probably predatory, and gives us pause to think about the legend of the roc, R-O-K, a predatory bird the Arabs encountered, had stories about it in medieval times. So all these large megafaunal animals are in the landscape and eating each other, eating the vegetation, and we have good records of some of them for what the landscape looked like. The surprising part of the story is that the light zones that we have around us, ponderosa pine probably wasn't here, pinyon pine also probably not here, but juniper and spruce and other conifers were in the landscape. Our light zones were 1,000 meters, 3,000 feet lower in elevation then. Places like Flagstaff were probably permanent ice fields, or had permanent ice fields. The peaks were undoubtedly permanently wrapped in snow in those days. So, the Ice Age is wrapped up about 12,500 years ago. Abrupt climate changes, more rain, and then aridification of the environment over the last 12,000 years has forced the life zones up in elevation, because everything about climate here is related to elevation in northern Arizona. We have these lake deposits from 50,000 years ago, 30,000 years ago, 20,000 years ago, showing us what these animals were doing in the landscape, what they're eating, vegetation that reflects very well on what the climate is. And it shows that our life zones actually transitioned really dramatically, particularly in the last 10,000 years. And perhaps very abruptly from 8,000 years ago to 6,000 years ago, which is a very severe drying phase. And not to cast aspersions on humans too much, but But the megafauna all disappeared except for a few species that we still have with us. Elk, deer, bighorn sheep, black bear. We had grizzly bear a while back. We actually had jaguar right here in the Flagstaff area up until the 1930s. So there were a few survivors of the Pleistocene megafauna still with us, but by and large, all the big herbivores died. Because they died, all the large scavenging and predatory birds passed away. California condor, we've been able to recover here, but that's a species that is well known from the Pleistocene times and actually survived that, only to face the modern challenges. Big transition in fauna. Probably the megafauna were perished because of contact with humans, beginning about 15,000 years ago. There was a paper actually 2 days ago, claiming that Native Americans have been in our region for 33,000 years, and I actually don't buy that because humans are pretty consumptive. A few thousand years is enough for humans to hunt out pretty much all of humanity. These kind of big game animals that we still see in Africa, where the animals have a long time to kind of figure out how to deal with humans. Also, some large forms live in Australia that also passed away because of human contact. So, big changes have taken place here, not only geologically and kind of physically in the environment, but environmentally as the climate has changed. And those climate changes, which we're undergoing another massive climate change right now, are shaping the way our flora and fauna are distributed. We will probably lose a lot of our big critters in the coming decades and centuries because of climate change. We're only really about 3 degrees temperature away from losing ponderosa pine here, I think. So, and the way these landscape transitions happen is through fire. A fire sweeps through, and there's no regeneration of that vegetation type. Some other vegetation type comes in, and now with the global mixing of so many non-native species in the landscape, we're getting new species that are moving in that we don't really know what the trajectory of their influence on the landscape will be. So, here we have a sloth turd comes out of a cave, and it exposes us to a story that is absolutely enormous in terms of its scope and our understanding of how dynamic the landscape has been here. And of course, this is one thread of many, many stories: dinosaur bones, algal mounds, plant fossils, the insect fauna that we have around us. Every species we encounter here has a story. And it has a story that goes back, like ours, almost 4 billion years on this planet. And how the various threads of influence on that species, evolution and its presence here, are just as miraculous as each of our own stories. And so that's that's what we get out from looking at turds and celebrating the scientists that have been brave enough to do an analysis on turds pretty much for their whole careers. Ken Cole, Jim Mead, certainly Paul Martin, real heroes in terms of interpreting these coprolite samples that we've been able to collect in the landscape. So with that, I think
we've got about 4 minutes for questions. So if you,
I got an online question for you. We got one from Laura online. Thank you, Laura. Fascinating to see how different the terrestrial food chain, grazers, browsers, carnivores were in the past. What is known about the aquatic ecosystems of this region at that time? Same group of fishes.
Same group of fishes?
Fishes, yeah.
So again, we have tools now that are kind of fabulous to be able to work with. Genetics especially gives us the ability to look at genetic clocks. How long have our fishes that are in our now rare streams, but the aquatic systems were more common back in the Pleistocene and certainly back in the Miocene. How related are our fishes? Well, our genetic clock data take us back about 10 million years, take us to the end of the Miocene period, the epoch. And that, so we can track some of our aquatic organisms. Spring snails, we have data that goes back that far. They're aquatic snails that live in individual springs. And the museum has just finished the biggest springs conservation project in the world, working on 100 species of spring snails and conservation planning for those in the states of Nevada and Utah. So those kind of stories get some attention and bring us back. Genetic work on, say, the genus Gila, which is a common form of minnow in our rivers here in Arizona. Those stories go back to the beginning of the Pleistocene, about 2.5 million years ago. And so we can see that those lineages were here in the landscape. They've evolved in place. They've gone through the various transitions with ice age, floods, and whatnot. And so we have some insights coming from that part of the story. Really interesting fish work on the continental divide, because we have fish genera that are on both sides of the continental divide. What's that mean? That means the continental divide has been moving over time, especially over the last 700,000 years, and capturing drainages that had those fish and sending them into the Mississippi system. So, you know, fabulous to be able to look at those fish taxa, their distribution. Again, these are data that are not very easy to assemble. It takes a lot of work. But and then looking at the genetics of those divided lineages to understand how this this issue of a mountain range rising and moving, actually physically slowly moving, capturing ranges affects the distribution of populations.
That's great. We've got time for about one more question.
You mentioned condors and how they historically fed on the megafauna, the corpses of the megafauna. Well, I've heard someone say that it's pointless to prop up the condor population as humans have been doing because their natural food is scarce.
Yeah. Conservation has a lot of challenges with it. What are we responsible for as humans? Are we actually stewards of the natural world, or are we just here to use it? And if we lose species like condors, who cares? I'm in the former camp, of course. Loss of something as magnificent as a condor because of human mismanagement of the landscape is inexcusable to me. We have plenty of cows and deer and whatnot that provide food for condors. Condors can fly on average 147 miles a day. So they have incredible mobility across the landscape. They hunt by smell, like the other vultures do. So the smell of death and poop, they're very sensitive to those odors and can track those. They go for a long time without eating also. Those are all adaptations that allow them to be.
So they're not dependent on us.
They're not dependent on us, but we're still influencing because they're very sensitive to lead poisoning.
Yeah.
And when hunters shoot deer and elk and leave the gut piles on the ground with lead in them, the condors pick that up. And it's an ongoing social debate. What should we be responsible for? And what do we want to leave as our natural heritage to our children? I'd be ashamed if something as great as a condor disappeared under the limited watch that happens.